Okay, uh, for this example, we are asked to find the total resistance seen by RCD and RAB. That is these 2 points. So what is the total resistance seen from here, and what is the total resistance seen from here? Now, for this particular problem and problems similar to this, you have to remember the following thing. When we are looking to the resistance from a certain terminal, that is, assume we have the following. This is just for the sake of explanation. Assume that we have the following connection, and we seek to find the resistance from this side. The idea is, if we connect this in the lab and we put the ohm meters connection on these two terminals, what are we going to see, or what is the ohm meter going to measure? Well, a shortcut to understand this is actually just think in terms of current. So pass a current from one of these terminals and imagine that that current should come out from the other terminal. In this case, you will find out which resistances are included. So we know that assume that we pass a current here, this current is going to reach this point, then it is going to proceed and it's going to go there. From here it will come back and add up to this guy and go out. So this resistance and this resistance, even though they are connected to these points, but they are really not in the circuit because there is no current going out. As the current cannot circulate back to the other terminal, from here back to the other terminal, since there is no path for that current, then these two resistances are not in our circuit. So please keep in mind that when you see such sort of a little bit complicated or tricky circuit, the first thing we need to think is in terms of current. If we pass a current here, that current should come out from this terminal C, and this is where are we going to put our ohm meter for this particular problem. And on the other way around, if we put the ohm meter in these two terminals, again, think that you pass a certain current from here, and that current should go back from here to the source. All right, let's see the first thing, this one, RCD. Maybe I can clean up a little bit. Okay, so we need to first examine which resistances are included in our calculations. So we pass a certain current here. Okay, so this current is going to go there, down, then come here, and this guy maybe come down, split here. But from this side, the current has no path back, and from this side. So practically, for an ohm meter put here in RDC, this one and this one are cancelled. They are not included in our circuit. The rest are included. Now, since the rest are included, we can now we have to use our imagination a little bit and redraw this circuit to be more become easier to look at. So imagine the following. I will put the point D here. So this is my point D. Okay, and look, this whole thing, this one, this one, this one, are really the same point. So all of that is D, and from that D we have a 60 ohms going down. This is this one, and from that same D, parallel to this 60 ohms, another 60 ohms. That is this one. Okay, and this is this point here that joins the two. Then from here we have, which is the same point here, we have 30 ohms, that is this guy here, in series with this 20 ohms, that is this guy here. And now we have our point C, which we need to put the ohm meter there, and from that C we have a resistor here of 10 ohms, and we need to find this total resistance between R, D and C, or CD. Okay, now these two are in series, they add up. These two are in parallel, we calculate them. The equivalent of these two in parallel is in series with the equivalent of these two, so they add up, and the total is in parallel with this 10. So to put some numbers, this is 60 ohms, this is 60 ohms, this is 20 ohms, this is 30 ohms. The two 60s, these two are in parallel, their total is 30. Here it is. Okay, let me put it a little bit more straight. Then we have here 10, we have here 50, and we are trying to find this one. So if this is 10 and this is 30, which is the result of these two 60s, and this is 50, which is the result of the 20 plus the 30, then we have 10 parallel to 80, and the total is 10 times 80 over 90, so it is 80 over 90 over 9 ohms. That is, if we put an ohm meter here, it will measure this value. Okay, now what if we change and we put the ohm meter on the other side? So if you go to the lab, maybe you can try this one, or you can use Multisim to try it. What if we put the ohm meter here? What is the reading of that ohm meter? So let me clean up. Okay, so we are trying to find the reading of this ohm meter now. Again, we say assume that there is a current going in, so this current is going here, it is going there, and there is a path for it to come back, and it can leave here. It has nothing to do there, but it will come back here, and it comes back to the end. In this case, we can think of these two guys, this 60. So this 60 is connected from this part, or from this terminal to this 60, and from this terminal to the 60 itself. So we have two 60 ohms resistances connected in parallel. That's simple, just calculate their total and we get or their equivalent, and we get the following. So this is now 30 ohms, which is the result of these two in parallel, and the rest is simple. This is 20, this is 30, this is 10, this is 80, and this is 40. Now these all together 60 parallel to 30, so 60 times 30 divided by the total, which is 90, we get 3, that is 20 when you solve this, so it is 20 ohms. So this whole thing now is this whole thing with this one. Okay, this whole thing is 20 ohms, and we get 140 in total because we have 80, 20 and 40 all in series. 80, 20 and 40 all in series, so the total is 140 ohms. Okay, see you in another example.